Hello everyone, welcome to this video. In this video we shall start with the topic of vector integration. All of us know how to perform the integration, right? But now let us see how can we perform this integration whenever we are talking about vectors. So ordinary integral in this case could be defined by this expression. So let us understand the notations first. So suppose you are given the vector r, which is a function of u. Now this is a vector quantity. This is a vector point function. So it has components in I direction, j direction and k direction. So we have these components here. This is k cap vector, right? So now what we are saying, suppose we wanted to take the integration of this vector point function r of u, then that integration is defined as, so basically what do, you take the individual integration of these factors. So that means I cap integration of r1u du plus j cap integration of r2u du plus k cap integration of r3u du. So basically this is the normal integration that we already know how to perform of simple functions. So we have converted our the integration of the vector point function here in terms of these three functions. So let us now discuss what do we mean by indefinite integral in case of vectors. So for indefinite integrals, we say, so if the given vector r of u could be represented by the derivative of some other function, where our other function is also a vector point function s of u, right? So in this case, we can calculate the indefinite integral of this vector point function r of u by taking the integration of the derivative of this function s of u, right? So when you perform its integration of this derivative term, so the effect of integration that will cancel out the effect of this derivative. So in effect you will obtain s of u, and moreover in this case you will also obtain the coefficient of integration. So notice here that this coefficient of integration, that is also a vector quantity, and it is not a scalar as we obtain in the case of normal functions, right? So this is how you define the indefinite integral in case of vector. So that means here in this case we also obtain a vector constant as a result of this integration. Moreover, we can define definite integrals. The definite integral of the vector function r of u between the limits u varying from the independent variable u varying from a to the point b, this could be defined in a similar manner. Here also we are writing this r of u to be the derivative with respect to u of some other vector point function s of u. In that case we define this integral to be equal to this particular integral, right? And when you perform the integration of this, the integration and this derivative, they cancel out each other's effect as in the previous case, leaving behind these limits. So that means we will calculate the value of this vector s at the point b minus the value of this vector s at the point a. So you have this quantity, and moreover this constant vector c will remain as such because the limits won't affect it anyway, because this is constant in nature. So this vector and this vector, they cancel out each other. So finally we have the vector s calculated at the point b minus the vector s calculated at the point a as the definite integral of the given function r of u. Okay, so let us see one problem related to this one. Now you might be thinking that this concept of integration is similar to the one which we have studied in school, so what's the use? So in this question you will be seeing the use of performing this vector integration in a more detailed way, right? So suppose you wanted to perform the integration of this particular function. Now this is a vector point function having t as the variable. So here t is the variable quantity. So here we wanted to perform its integration. So what is the rule here? The rule is to perform this integration over all of these terms separated, right? Because this integration, we know integration, that is a linear operator. So using this fact, we just separate out all the terms consisting of I cap, j cap and k cap separately, and then it reduces to solving simple integrals. So what these become equal to, when you perform the integration of t, that becomes equal to t square by 2, and the limits vary from 0 to 1. In this case, integration of t square is t cube by 3, integration of 2t is t square, integration of 3t square is t cube, and 3t cube is 3t to the power 4 by 4, and in all the cases you have limits varying from 0 to 1. So when you substitute the limits, you obtain this as the final vector. So this is the vector which is obtained after performing the integration of this particular function. So I hope you understood this concept of vector integration. We'll see in depth these topic in the later videos. So well, that is it for this video. Thank you for watching.